You ever been deep in a game, right? You smash a button and bam, your character just reacts instantly. Well, every single time you do that, something pretty incredible is happening inside your computer.
Yeah, exactly. How does that even work? How does a simple button press turn into this big, complex action on your screen in, like, a split second? To figure that out, we've got to look inside the computer's brain.
And that brain, it's this tiny but super powerful chip called the Central Processing Unit. You've probably heard of it, the CPU.
So this is the place where all the magic happens, all the thinking. It takes every single command you give it, whether you're jumping in a game or just opening an app, and turns it into an action. But like, how does it actually think?
Okay, so thinking isn't exactly the right word. It's not thinking like we do. What it's really doing is following this super fast, endlessly repeating three-step dance, basically. Okay, here's how it goes. First, the CPU will fetch an instruction from memory. Think of it like grabbing a recipe card. Next, it has to decode that instruction to figure out what it's supposed to do. And finally, it will execute that command. Fetch, decode, execute. That's the core cycle that turns your button press into what you see on the screen. So what does this actually look like happening inside the processor? Well, picture a tiny, ridiculously high-speed command center.
All right, the boss of this whole operation? That's the control unit, or CU for short. Okay, team, new instruction coming in. Add 3 plus 5.
The CU immediately barks its order at the registers. Now, you can think of these guys as super fast sticky notes that hold just the info needed for the task at hand. CU voice. Register, you're up. Grab that instruction. So the control unit decodes the instruction. It looks at it and goes, aha, a math problem. And it knows exactly who to call.
Decoding? Okay, it's an addition problem. This one's got your name on it, ALU.
And that would be the Arithmetic Logic Unit, the ALU. This is the math whiz of the CPU. It crunches the numbers in like no time. ALU voice, 3 plus 5 is 8. Done. Register voice. And I've got the results stored. What's next? Come on. Okay, hold on. That's one calculation. So how does this all happen fast enough so my game doesn't feel like I'm watching a slideshow? Well, the answer to that is something called clock speed. This is what measures how many of those fetch, decode, execute cycles a CPU can blast through every single second. So a modern processor might have a clock speed of, say, 3.2 gigahertz. You'll see it written as GHz. Now, that sounds fast, but what does that number actually mean? It means that that tiny three-step dance we just saw, it happens over 3 billion times every single second. That is what makes a computer feel fast or slow, and it's why your game feels completely instantaneous. So when you boil it all down, pretty much everything your computer does comes back to this one simple, relentless, and unbelievably fast cycle. It's literally the heartbeat of all modern tech.
Fetch, decode, execute. That's it. That's the pulse of the processor. Kind of makes you wonder, right? What other simple, repeating cycles are out there, quietly powering all the complex tech we use every day?